this is a split operation. So this is a move copy operation, as I say, and align operation. Now let's have a look at the split operations, which are very important in Gambit. So split edge needs the edge you want to split and the split type and the split tool. So that is what it needs. So it splits the real edge. As I said, it splits real edge. It means if it is a virtual edge, you cannot split that edge. So this is one limitation of the virtual geometry. Virtual geometry split operations are not allowed. It is not possible because they don't have any mathematical definition, they don't have any geometry, and now you are talking about dividing that geometry into two parts. So that is not possible. So split or non-real edge creates two virtual edge. So there are different split operations. Split operation divides one edge into two edges. That is what split operation does. There are different operations, as I say, split types: real connected, real disconnected, and virtual connected. So what real connected does is, let's say you have one edge, you are dividing that edge into two parts. Now after dividing a edge into two parts, whether these two edges are going to share a common vertex or not. If they are going to share a common vertex, that is called as real connected. It means I am going to divide one real edge into two real edges. After division, those two real edges are going to have a same vertex common in between. So that is why they are called as real connected split. If I say real disconnected split, then again I have one real edge, it is going to be divided into two real edges, and after division there will be no common vertex between them. The common point which is there, again, that is like you do a real connected split and then you do a disconnect operation. That is nothing but real disconnect split. If you talk about virtual connected, one edge is virtually going to be divided into two edges. It means one real edge is going to be divided into two virtual edges, which is called a subset virtual entity. If you remember, one real edge is going to be divided into two virtual edges and they will be sharing a common vertex in between. So that is nothing but virtual connected operation. So connected is nothing but common vertex, disconnected is nothing but no common vertex, real is nothing but real split, like mathematical definition is there. Virtual is nothing but just a virtual split, just for changing the topology. So these are the split tools available. Point, it means if you have a edge, you can specify u value on the edge. U is equal to 0 at the start, which is nothing but a start point of the edge. U is equal to 1, which is nothing but the end point of the edge. So you can provide any u value between 0 to 1, and that point will act as a split point, and using that point it will do a split operation. If you talk about a split tool, which is a vertex, so if the vertex is present on the edge, then you can do a real vertex split. It means there is one vertex which you have created using might be the operation called as vertex on an edge. You can use that vertex for a split operation. If the vertex is exactly on the edge, then yes, real split is possible, but if vertex is not exactly on the edge, then you can do a virtual split operation. So you can in fact use vertex as the split tool. We will see this. You can also use edge as the split tool. So as I said, let's do the split operations. So I will say, okay, I want to split this edge into two edges. So I will go to split edge, and this here you have to select which edge you want to split. Here you have to say type of split: real connected, real disconnected, virtual connected. Here you have to select the type of the split tool you are using. Point, vertex, and edge is also there. So let's say I want to do a real connected split of this edge, and my selection or the split tool is point. So I can always drag this point to some other location. And if I say apply, which is right click, if you see, this edge is converted into two edges, and now this vertex is a common vertex between these two edges because I have selected real connected. So this is nothing but real connected. Let me delete the faces because I want to do a real disconnect operation. I cannot do it unless and until I delete the faces. Apply, sorry. So face delete, delete the faces, select all the faces without lower topology and apply. Correct, I got only edges. Now I can go and split edges, and I will say real disconnected, and again split tool is point. So I will select this edge, this is the location of the point. I am not happy with this, I will drag it somewhere else, and I will say real disconnected, apply. Now if you see, at the same location two vertices are created. If you see here, created vertex dot 10, because it is disconnected, the split is disconnected kind of split. If I go to summary, again box selection, and if you go here, it has selected two vertices, which is vertex 10 and vertex 11. So they are definitely disconnected. Again I go to summary, select this vertex, apply. This vertex is assigned to edge dot 7, vertex 10 is assigned to edge dot 7, and again if I do here vertex 10 next vertex, which is vertex 11. So if I say right click, the summary of that, if I have a look at the summary of that, that is edge dot 9. So definitely there are two vertices. So because I have done real disconnect operation, real disconnect means it has converted one real edge into two real edges and they are disconnected. Again if I go to split operation, split edge, and then I will say virtual connected. Then if I select one edge, let's say this edge, and apply, if you see this edge is converted, the initial one real edge is converted into two virtual edges and they are connected to each other. So this is a common point, common vertex in between. So this is about these three split types. And then there is also a split method or split tool, which is nothing but vertex. It means if you have a vertex present on the edge, let me create vertex on the edge. So I will say on edge, this, apply. If I have vertex created on the edge, I can always use that vertex for a split tool. So I will say real connected again. The split method is vertex. A split width is vertex. So select this edge, then this vertex, say apply. So if you see, that is converted into a yellow color, it means now it is a part of a edge and it is common between these two edges. So that is nothing but vertex. If you have vertex which is there on the edge, you can always do the split operation, but I can do a real split only when that vertex is exactly on the edge. It means, or it is in a 10⁻⁻⁶ tolerance. But if the vertex is at some other location, so I will say okay, I will just move this vertex in positive x direction by, let's say, 0.5. Now if you see, this vertex is not exactly on the edge, I cannot do the real split operation. So I cannot say real connected, let's say this edge and this vertex, I cannot say real connected, because it says that it is not within the tolerance which is specified, which is nothing but 10⁻⁶. But I can always do virtual connected operation. So if it is virtual connected operation, it will ask me tolerance. So let's say the tolerance is the distance between these two is 0.5, so I will provide tolerance 0.6, and I will again select this edge. So again I will say my connection is virtual connected, my split tool is vertex, and then I will select this edge, this vertex, and my tolerance is 0.6, and I will say apply. If you see, it has done a split operation, but if you see carefully, the location of the split is like a interpolation between the, it means the position of the split is exactly the interpolation between this edge. It is at the center between this vertex and the edge. So that is because we have activated interpolate. Now if you want to preserve the vertex location, you can activate preserve vertex location. Again I will select this edge, this vertex, the tolerance is 0.6, and preserve vertex location. If I say apply, if you see, vertex location is preserved, it means it is not moved. But this is, again, if you see, the geometry of the edge is very bad, so most of the time I will say preserve edge shape. So again I will go to this edge and then this vertex, I have already activated preserve edge shape. I will say apply. If you see, now the proper operation is done, this vertex is projected on the edge and then it is used as the split tool. So that is nothing but interpolate, preserve vertex location, and preserve edge shape. and this is about virtual connected, real connected using vertex as a split tool. So this is what like I have explained. Interpolate, if this is the vertex location, if this is the edge location, the interpolate is nothing but this particular vertex which is going to be created, that is the interpolation vertex. It means the position will be interpolation between the edge and the vertex. If we say preserve first, preserve vertex location, this is vertex location which will be preserved, and preserve edge shape is nothing but the edge shape will be preserved and the projection of the vertex will be done. So this is again a edge as a split tool. It means if you have two edges which are intersecting with each other or which are not intersecting, then you can control it by tolerance. So if you have two edges, so let me create two edges. I will just say reset and again use the graph paper, fit to screen, front view, then control click. Let's say I am going to say this point and this point, and let's say this point and this, let's say this point, and then again don't show me graph paper, apply, create a edges, straight edges between these vertices, this vertex, this vertex and this vertex, apply this vertex and this vertex, apply. Correct. Now these two edges are intersecting with each other. So what I can do is I can actually split one edge with another edge, split edge. Now my split tool is edge. So there are different options popping up. I will explain those options. So select this edge. I want real connected. Select this. Something has happened to Gambit. So I will say exit, fit to screen, fine, exit. I don't want to save the session. So I have restarted Gambit. Again let's create a graph paper, update list, apply, and let's create some points. Let's say control right click, control right click, control right click, and control right click. I don't want to see the graph paper, visibility off, apply, and now let's create the straight edges, geometry, straight edge, and let's say between this point and this point, and then this point and this point, create the straight edge. Now these two edges are intersecting. I can use one edge as a split tool for another edge. So if you go to edge, split edge, then I can say my split tool is edge. I want to have a real connect split. So what I will do is, let's say I want to split this edge using this edge, apply. If you see what is done, the split tool is deleted. It always deletes the split tool by default. The split tool is deleted, and now what is done is this one edge which was there, that is divided into two edges. So it is splitted into two edges using that particular edge. Now if I want to retain that particular edge which I have used as a split tool, so I can always retain it. So this edge I want to split with this edge. I don't want to delete this edge because I might use this edge for some other operation. So I will say retain and apply. Again what it has done is, this edge is divided into two edges. One is this, another is this. This is divided into two edges, and the split tool which you have used, that is retained. So that is not deleted. So that is what a retain operation does. Now again if I say bidirectional, I will select this edge. For example, I will select this edge which I want to split. I will select this edge, the edge which I want to use as a split tool, and then if I say bidirectional, so what it does is, it does divide. It divides this edge, it split this edge into two edges by using this edge. That is the first operation it does. So this edge is divided into two edges. The second operation it does is it also divides this edge which is used as a split tool into two edges by using this edge. So that is nothing but bidirectional. So what I got at the end of the split is 4 edges, 1, 2, 3, 4, and they are sharing a common vertex. So if I go to vertex and if I say summary of the vertex, this vertex, if you see, that is common between the 4 edges, edge 1, 4, 3, 2. So that is nothing but bidirectional split, and which is very useful tool if you want to do a connect, or if you want to get the connected geometries or something. So this is nothing but split edge, retain and bidirectional. When you say retain, the split tool will be retained. When you say bidirectional, the split tool will be also splitted into by using the target edge. This we call it as a target edge. So that is nothing but split edge. So this is retain split tool, edge is not deleted. Bidirectional, split both the target edge as well as the split tool edge at their point of the intersection or the closest approach. We will see what is closest approach. The target edge and the split tool edge are joined together at the split location, and tolerance is nothing but proximity of the split tool to each other. It means if the two edges are not intersecting with each other, I can always say real connected and then edges, and then I can control it using the tolerance value. By default tolerance is 10 raised to minus 6. So that is nothing but a tolerance, and this is nothing but a split edge operation. So these are the different splits that you have, these are the different split tools that you have. This is the first one is point split. It means use a point as a split tool, you provide the u value on that edge, it will do the split operation. The second is vertex, interpolate, preserve, a vertex location, preserve edge shape is there for virtual split operations. And then split tool is edge, so retain and bidirectional is there. The next operation is nothing but merge operation. What it does is it merges the two edges into one edge. So I will just delete this edge and this edge. Now I can always merge these two edges. It is reverse of split edge. I can merge these two edges into one another. So I will say this, I want to merge this and this edge, apply. If you see, that edge is merged into two edges, edges are merged into one edge. But for this merge operation there are a lot of constraints. The first one is nothing but these two edges that you want to merge, they should be connected to each other. It means they should have a common vertex in between. So that is the first rule for merging. So we will have a look at all those rules. So it merges two or more real or virtual edges. Identical boundary zones will be assigned to newly created. It means if the edge is acting as a wall, it will act as a wall, after merging operation also. Merge rule is what? Edges must be connected at one or both the end. It means edges has to be connected to each other. The connected end point should not be connected to more than two edges. So as I said, the general rule in Gambit is it will not allow you any operation which will violate the definition of one entity. So if I have two edges, let's say edge 1, edge 2, edge 3, I can always merge these edges together, edge 1 and edge 2 and edge 2 and edge 3, something like that. I cannot merge these edges because there is no common vertex in between here. There is no common vertex in between in this particular, this is disconnected. I cannot also merge this because I cannot merge this because this particular vertex is also part of this edge 2. So if I am going to merge these two edges, this vertex is going to be deleted, which is not allowed, because if I delete this vertex, this edge 2 will lose its definition. So real and virtual forced, different merge operations are available. If you have a look at this, this is real and virtual tolerance. So real and virtual force, it merges the edges regardless of their respective lengths or angles with respect to each other. Real edge only if the edges to be merged are real and similar to each other. It means I can merge these two edges. I will see virtual tolerance and then we will come back to this particular merging. Virtual tolerance, it creates the virtual edge if all the edges in the set meet the specified tolerance criteria. What is the tolerance criteria? The maximum edge length and the minimum angle. For example, if I have these two edges, let's say this length of this edge is 5 and length of this edge is 6. Now if I provide my maximum edge length as a 4, it means none of the edge is satisfying this criteria. It means none of the edge has a length which is less than 4. So, it will not merge that edge. So, this tolerance is nothing but many times what happens is we do not want to have a edge in the geometry below particular length. So, what you can do, you can use this particular operation. You select all the edges, might be 1000 edges, you specify this criteria. Let us say I want to merge a edge whose length is below 4, that is actually a short edge for me, that will create bit complicated model for meshing. So, I will specify that as a edge length, let us say 4 as a edge length, and then automatically what Gambit will do is Gambit will check the length of every edge, and if the length is below 4, it will do the merging, it will try to merge it into the connected edges which are adjacent, and if the edge length is more than 4, it will not do the connect operation. So, that is what is nothing but maximum edge length. So, minimum angle is, so again in this case, if the minimum angle is, if the angle between the two edges is less than the angle which I have specified, then it will not do the merging operation. It means if the angle which I have specified is 260, then it will not do the merging operation. This is allowed, or this is helpful in creating this is helpful in avoiding the very complex definition of the edges. It means if the edge is there and if the included angle between the edge is very small, then the meshing will be very difficult for that particular edge. So, it will this particular angle criteria will restrict us to merge the edges whose angle it will restrict us to merge the edges whose angle, in between angle is less than the angle which was specified. So, if the angle is less than 260, here I am giving you can say this is one case, two edges are there, angle in between is 180, and if I have provided angle 260, as this 180 is not, or 260 is not less than 180, it will not do a merging operation. So, that is nothing but with tolerance. It means you can control the virtual, in this case for example, I have to check what is the edge length. So, summary, this edge, apply 4, and this edge, this is also 4. Okay, fine. I will do one split operation, split edge, I will do a split edge with a point, apply, and this edge length is, again go to summary, this edge length is 1.11. So, let us say I want to merge this particular edge into this, because this edge is a small edge for me. So, I will say merge edge, and then I will say virtual tolerance all, and let us say my length is 2. If I say apply, if you see only this particular edge is merged into the adjacent edge, because the length criteria which I specified is 2, and only the first edge is satisfying that criteria. So, that is merged. Or similarly, I can say virtual tolerance, I can provide angle, let us say 260, pick all, and if I say apply, nothing is merged because the angle is 180. But if the angle is, for example, less than what I have specified, pick all, and let us say angle is 90, apply, so everything is merged. So, you can have a look at the effect of this angle. Basically, this angle will not, this angle will restrict us not to create a very complicated edge definitions. And real and virtual forced is nothing but merges edges regardless of their respective lengths or the angles with respect to each other. It always does, if real merge is available, possible, it means if the two edges which need to be merged, if the two edges are real or if they are similar to each other, then real merge is possible, else it will always do a virtual merge regardless of whatever the angle or the length in between. So, that is nothing but real and virtual forced. The next operation that you can do on edges is nothing but smooth heel edges, replace bad geometry and reduce complexity is there. These two operations that you can do. Let us have a look at these two operations. What it does is, all these operations, smooth real edges, automatically repairs the edge geometric conditions that might cause, see ANSYS geometric modeler has its own constraint. It means it has to be in a proper definition, or it has to be in a proper definition which will be understood by ANSYS. If it is not there, then those geometries are treated as invalid geometries. So ANSYS in fact has a tight distance tolerance because of high precision. Generally it look for 10 raised to minus 6, and there should be a completeness of the connectivity information. ANSYS requires these two things. There should be a very tight tolerance and a completeness of the connectivity information has to be there. Many times Gambit model many times the model which is generated in Gambit meet these requirements always. Some operations may produce the geometry which fails the above requirement. So if that is there, we can use this operation. So geometry imported in Gambit may not meet the above, most of the time what happens is, if you have created a geometry in Gambit, then definitely it will meet the requirement because it is created by ANSYS geometry kernel itself. But if you have created a geometry in some other CAD software, it might not require the constraints which are there, because in that CAD model, let us say the tolerance level is 10 raised to minus 6. If you import that, the tolerance level in Gambit is 10 raised to minus 6. So definitely it will not understand the things which are connected there, it will be disconnected here. So this is one thing, because of the tolerance limits which are there different for different systems. It is because of the data transfer through neutral file format. It means if I am creating a geometry in SolidWorks, probably I will be taking that geometry into Gambit through IGS or Parasolid. Once I do that, if I do that translation, depending on how effective your translation is, there will be some kind of data loss will be there, and there will be always a difference in the tolerance settings between Gambit and the geometry model. So because of this, there will be inconsistency in the model. It means the model which is closed in SolidWorks, it might be open in Gambit. So because Gambit uses ANSYS, which requires some typical, you can say, which requires some typical constraints, which needs the geometry to satisfy those constraints. So smooth real edge operations allows us to automatically repair those kind of problems which are there. So smooth real edges has two operations, which is replace bad geometry and reduce complexity. So what replace bad geometry does, it reconstructs the underlying curve associated with any edge being smooth. Both the operations allows the tolerant modeling. Tolerant modeling is nothing but to just redefine the connectivity. It will redefine the tolerance values for edges. It means if the if two edges requires tolerance level, let's say 10 raised to minus 3, it will check and it will check and it will go and it will check what is the tolerance level which is needed to connect the geometry, and it will assign the tolerance level for that edge. For another edges, the tolerance level might be different. So that is nothing but making the model tolerant. So the Gambit automatically assigns the tolerance value to each imported vertex and the edge to maintain the topological integrity. That is what I said. The tolerance values for each vertex and the edge will be different to maintain the integrity of the model. So import an edge, for example, import an edge one termination point of which does not coincide with the corresponding endpoint vertex to within 10 raised to minus 6. What Gambit does, Gambit assigns a specific tolerance value to the vertex such that it becomes coincident. That is nothing but tolerance model. All these operations should be carried out as soon as the edges are created or imported. Whenever you import the edges or create the edges, and if you feel that there might be some problem in the geometry, as soon as those edges are created, you have to carry out those geometrical operations, and it should involve as many edges as possible at one time, because it might happen that it will assign the tolerance value to one edge, and if you have not selected the adjacent edge, the tolerance value will be different. So as many edges as possible as soon as those edges are created. So what replace geometry does is, it detects any edge that possesses bad geometry, like including discontinuity like G1 and C1 discontinuities, and it attempts to reconstruct the edge to repair the geometry. It means it will try to reconstruct the edge so that those continuities will be maintained. Reduce complexity operation does what? It redefines the spline behind the nerves curve, or for it redefines the spline definition of underlying curve, and it is applied to only to the spline definition. So it will try to reduce the number of control points, because if the number of control points are more, then the spline definition will be very complicated. So we are going to have a look at the spline and nerves and everything in our basic geometry modeling lecture. So the tolerance operation does what? The tolerance which is there in the form, in replaced by geometry form, it allows a gambit to change the location of the control point so that the spline definition will be bit simple. So that is what it does. This is the typical form for smooth real edges. So you have to pick the edges, as many edges as possible, and say replace geometry, bad geometry or reduce complexity, and then you have to provide the tolerance. Tolerance is nothing but with what value the control points can be moved. This is nothing but convert non-real edges to real edges. Many times, as I said, the virtual edge of, if you have virtual edges, there will be a limited operations available on the virtual edges, so you can always convert the virtual edge into real edge. Internally what it does is it creates the facets of the edge and then it fits the point with the spline. So that is what it does. Facets is nothing but, imagine that you have one virtual edge. First thing it does is it creates the mesh on the virtual edge, and one you can say element is one facet, and using those grid points it tries to fit the spline in between. So you can always control in how many grid points that you want to divide that particular edge. Those are also called as sampling points. So internally basically it will create the mesh, not, I mean, it will not be visible. So if the mesh is already present on the edge, it will use that mesh, or if mesh is not present on the edge, internally it will create the mesh. Every node will act as a control point of the spline, and then it will try to fit the spline. So that is how the non-real to real works. So these are other operations in on you can say edges. One is display the summary, then check the edges, topological check or geometry check. What topological check does is lower topology vertices are visible or correctly referenced or not, upper topology faces correctly referenced edges or not, upper topology faces maintains the correct sense in the information of the edges or not, virtual guest entities or host relation is there or not. So this is what the topological check does. Geometry check does what? All real edges correctly references ANSYS model or not. It means is it there, the mathematical definition is there or not. Any virtual edge hosts are of a correct type or not. It means if there is a virtual edge, what is this host? Is it a correct type, or is there any relation? I mean, is the relation proper or not? That is what it will do. Check operation. Then this is nothing but query operation, query edge. If you want to know the label of the edge, you can use query edge. Sum is nothing but it will give the summary or of the number of total edges and geometrical entities as well as mesh. Delete edges, delete the edges. So these are other operations available. As I said, this is nothing but smooth hill edges. This is nothing but convert edges, non-real into real edges. This is summary, give the summary of the edges. So if I select this particular edge, it will give the summary in the transcript window. Then this is nothing but check, it will check the geometries for connectivity as well as topology. So here you have to get this kind of message, 0 out of 1 edges failed for validity. If there is one edge, any edge failing for validity, you have to repair that edge and you have to make sure that that is passing this check. Query is nothing but it will allow you to have a look at the edge and its label, to correlate the edge and label. And this total is nothing but it will give me total geometrical entity. So in this case I have only one edge and two vertices right now. Delete is nothing but it will help you to delete the edges, and then if you don't want to delete the vertices, you can deactivate lower topology and delete the edges. So in this case, as it was a virtual, I have deleted only the virtual entity, so the real entities is popping up which were in the background. So these are all the operations that we can do on edges. So till now we have seen operations on vertices, operations on edges. In next lecture we are going to have a look at the operation on vertices. Thanks a lot. Next edge we are in next lecture we are going to have a look at operation on faces. Till now I guess everybody is familiar with edge and vertex creation. Thank you.